Okay, I had to restart because of a surprise bell announcement. So the area of a kite is 1/2 d1 times d2, just diagonal 1, diagonal 2. Our two diagonals are 30 and 14. So we're just going to multiply 30 times 14 divided by 2, or you can do mental math in your head. Half of 14 is 7. 7 times 3 is 21. So area is 210 square inches. All right, number 3. We have a regular pentagon. So we're going to use the 1/2 apothem perimeter. Now, right off the bat, we know 6 times 5 is 30. So we know the perimeter is 30, but we need to find out the apothem. So we take our triangle. Remember, since this is regular, this central angle is going to be 360 divided by 5. This is very good practice because you got to be comfortable with doing this. And that's going to be 72. Which then, if we go to our half triangle, we bisect it with the apothem, that is going to be 36. Now we're trying to find the apothem right here. I could call it A if I want. Now remember, if I'm cutting this, and this whole length here is 6, that makes this 3. Now I'm trying to find the adjacent side. I have the opposite side, so that's tangent. Tangent of 36 is opposite over adjacent. TOA. So therefore, I'm going to switch places. X equals 3 divided by tan of 36. And I just type that in my calculator. Make sure you're on degrees, not radians on your calculator. And I get about 4.13. And that's okay, that's rounded. It's 4.129. So I have my apothem, I have my perimeter, so I'm ready to go. Area is 1/2, 4.13 times 30, or 15 times 4.13. And that's going to give me an area of 61.95 centimeters. And remember, don't round it to 62, leave it as a decimal to show that it's not a whole number. Okay. Use this information, again, as reviews, keep everything fresh. The center is 2,5. The radius is 7. So that's x minus 2, and we square it, plus y minus 5, and we square it, plus 7 squared. And then just to clean it up, that's supposed to be an equal sign there. It's silly of me. I don't know why I put a plus sign. I maybe even said equals, but I wrote plus. 49. And that's the equation of that circle. This one, the center is 8, -4. So that's going to be x minus 8 squared plus, remember, this y minus a -4. Be careful with that. Squared equals, oh, well, we don't know, do we? The point is on the circle at 0, -4. We don't have the radius. So let's think about this, whether we need to use the distance formula or not. We have a point at 8, -4. 1, 2, 3, 4, 5, 6, 7, 8. -1, -2, -3, -4. So we have a point that's, of course, underneath that blue bar there. So right about there. Let's just say there's the spot, 8, -4. Well, our point is at 0, -4, which means this right here. So no, we don't have to use the distance formula. We can just count and find out that the radius of this circle is 8. That's a horrible circle. But that's what it would be, 8. So this is going to be 8 squared. Now, if this was at 0, -3, we could not count. We would have to use the distance formula between the 2 points. But whenever there's a shortcut, take it. So this cleans up to x minus 8 squared plus y plus 4 squared equals 64. All right, on to new stuff. More formulas. Formulae. Volume of a pyramid. So this is basically just a very simple formula. You take the base, the area of the base, capital B is the area of the base, okay? Divide by 3 and multiply by the height. And the height is from the bottom to the top point at a 90-degree angle. So find the volume of the pyramid. So for example 1, first off, we have a right triangle on the bottom. Okay? So the area of the base, being a triangle, is 1/2 base times height. And this can get confusing when we start throwing around the word base multiple times. But we're just looking at this right triangle. Okay? And we're looking at base and height of this triangle, 4 and 6. Okay? So if you get confusing, just pay attention. I usually just think about, let's look at the two-dimensional object first, then bring it into the three-dimensional object. So my two-dimensional base and height is 6 and 4. So 1/2, 6, 4, which you can do in your head. Half of 6 is 3, times 4 is 12. So the area of the base, capital B, is 12. The height is 9. So again, the area of the pyramid, going to go with the formula again, is 1/3 area of the base times the height. And again, you can do this in your head, because 12 divided by 3 is 4, times 9 is 36. Now, this is, I'm sorry, why am I saying area? It's volume. We're finding the volume of a three-dimensional object, silly. So capital B is the area of the base, V for volume of the shape. So the volume is 36 meters cubed. We always cube because it's a 3D object. Okay, originally Caphre's pyramid had a height of about 144 meters and a volume of 22,18800. So 2,218,800. Find the side length of the square base. Well, let's think about this. First off, we have a square base coming to a point, right? And being a square, all the sides are equal. So length and width are the same. So that means we're just going to square root somewhere in here. Now, let's go back to the formula. Volume equals 1/3 area of the base times the height. Okay? We know, now we're working backwards here. We know the volume. So we put that in. 2,218,800. Equals, we know 1/3. Now we don't know the area of the base. But the base, if you think about it, is just, and you don't have to do it this way, but this is one way to think about it. You can put a capital B here and work backwards. But if you think about it, it's just one side squared, right? So if this was, one side was 3, it'd be 3 times 3, base would be, area of the base would be 9. If it was 17, you take 17 times 17. So this is one way to think about it. Remember, we're going to be doing square root, but we'll talk about both ways. And then the height we know is 144. Okay, now, the thing is, does 3 go into 144? Because basically you need to multiply 1/3 times 44. And it does, it's 48. So this side over here, this times this is 48. So I'm going to divide both sides by 48. Okay? And when I do that, I can go 2,218,800 divided by 48. And that gives me 46,225 equals, now remember, we could say it's the area of the base, or we can think about it as s squared, because it's a square. So we're going to square root both sides, and the square root of 4,6,225 is 215. So that means one side equals 215, what was it, feet, meters. All right? So this is 215, this is 215, the height is 144, And the volume of that pyramid is 2,218,800 cubic meters. Okay, example 3. Find the height. So again, we're going to be working backwards. I'm going to start by writing my formula. 1/3 area of the base times the height. What do I know? I know the volume is 14. I know my 1/3. Do I know the area of the base? Well, I have to calculate that. Now what I have here is I have a triangle with this information in it. Well, that means the area of this triangle is 1/2 times 4 times 3. So that's 6. So the area of the base is 6. And my height is what I'm trying to figure out. So I'm going to work backwards again. 1/3 of 6 is 2. So I'm going to divide both sides by 2 and find out that the height is 7 feet. Now, if you need to take the extra step of writing it out, that's fine. It'd be 14 equals 2h, and then you divide. All right, next example. Example 4. A and B are similar. Find the volume of pyramid B. Okay, so for this one, it's actually easier than most. There's an extra step involved. So first off, we need to talk about the scale factor, okay, of the two triangles. So volume of B and the volume of A. So let's look and find out what scale factor is for the two pieces of information we have. We have the heights. So the scale factor on the heights are 3 to 4, which basically is 6 to 8 reduced. Okay. So we're going to use this to calculate the similar value. So if we have the volume of B over the volume of A, right, and we're talking about the scale factor, and remember, when we talk about cubic scale factor, it's cube. When we talk about area, it's squared. So we just take the 3 and the 4. Well, we do know we can substitute in the volume of A being 96. And now it's just a simple matter of calculation. So the volume of B over 96 equals 3 cubed over 4 cubed. And now we just cross multiply and divide. 27 times 96 divided by 64. And the volume of B is 40.5 cubic meters. That's it. And last example, 5. This is a composite solid. Composite means you're putting more than one shape together. So basically we have a cube and we have a pyramid. So the volume of the cube, which I draw a square, is length times width times height. Okay, so 6 times 6 times 6. Which is 216. So that's the volume of the cube. Now we need to find the volume of the pyramid. Now, remember this is 6 and this is 6. The volume of the pyramid is 1/3, we just learned, right? Area of the base times the height. Well, 1/3 we know. Area of the base is 6 times 6, 36, and the height is 6. So again, you can do this in your head if you want. 1/3 of 36, or easier, 1/3 of 6 is 2, times 36 is 72. So, cubed. That is the volume of the pyramid on top. If we add those two together, we get 288 cubic meters.